Today we're going to look at section 3.5. This is on graphing quadratic functions. Quadratic functions will always have the standard form, or they can be written in the form of f of x equals ax squared plus bx plus c, where a, b, and c are all real numbers. That's what this symbol right here means, element of the real numbers, and a is not 0, because if a is 0, this first term would disappear and it would just be linear. We've seen this before because we used that when we were solving quadratic equations. So the form that we'd like to see it in is called standard form or vertex form. The one up here is general form. And we have f of x equals a times x minus h squared plus k. The thing that we want to note here is that h and k make up the vertex. Or if you think about the translations, this is h units to the right, and this is k units up. So again, standard form or vertex form just tells us really where has this thing been moved. So the vertex, like I said, is h comma k. If a is greater than 0, that means it's positive, the parabola will open up. That would give us a vertical stretch or a vertical shrink, but no reflection if a is positive. On the other hand, if a is less than 0 or a is negative, the parabola will open down because it has now been reflected over the x-axis, just like we talked about in the previous section. As we look at this, we want to do that process that we did before called completing the square. And to do that, the first step is we have to get rid of this constant. So we subtract 23. Our next step, if you recall, is we've got to get the x squared by itself. So to do that, we divide every piece by 2. So now we have f of x minus 23 over 2 equals x squared minus 6x. Now here's the part that people sometimes forget how to do. We want to complete the square, so we have to put this something squared here. And the way we get that something is we take half of this, negative 3. Negative 3 squared is equal to positive 9. So what we have to do on this side is also add 9. So now we have f of x minus 23 over 2 plus 9 equals this perfect square, and the perfect square is x minus 3, and we get that from here and here. So now we have to put everything back to the right except the f of x, so we subtract 9. So that's gone. We're going to multiply by 2, and when we multiply by 2, we have to multiply everything by 2, the entire side. So now we have f of x minus 23 equals 2 times x minus 3 squared minus 18. Then our last step, add 23. So we get f of x equals 2 times x minus 3 squared plus 5. So that gives us our function in standard form, and we remember that our first description is that the parabola has moved to the right 3 units because of that x minus 3. Then, second, it's a vertical stretch by a factor of 2. So we know it still opens up. It's just a vertical stretch. It's not reflected. And then the last thing that happens is this plus 5. So that's going to move it up 5 units. So now when we talk about maximums and minimums, if a is greater than 0, a minimum of f occurs at x equals h, and the minimum value is f of h, which equals k. A being greater than 0 means this thing opens up, so it has a lowest possible value, and we call that a minimum. As you can see there, we know it opens up, so it has a bottom, a lowest value. If a is less than 0, a maximum of f occurs at x equals h, and the maximum value is f of h equals k. So the function, or the parabola, opens down, so it has a top value. Notice there's no difference in this part. The only difference occurs based on a, and that tells you, does the parabola open up or does the parabola open down? But the maximum value or the minimum value always occurs at the same spot. Now, as we look at a function like this, we can use the process of completing the square to help us put this in standard form and find the vertex, which is going to be the maximum or minimum. So again, the first thing we do is we subtract the constant, 49. Then we're going to divide everything by 5 to get the x squared by itself. So f of x minus 49 over 5 equals x squared minus 6x. Well, unfortunately, this is a little bit boring. That b value is exactly the same, but we take half of it, and that's squared, and that goes right there. So this is really adding 9. We have to add 9 here as well. So f of x minus 49 over 5 plus 9 equals our perfect square, which is now x minus 3. And again, that's from here and from there. Now we put everything back. We subtract the 9. We multiply by 5. And remember, we multiplied both things over here by 5, so the parenthesis becomes 5 times x minus 3, and then this becomes 45. And then our last step is we add 49. So f of x will equal, standard form is going to be 5 times x minus 3 squared plus 4. Now think about what has happened here to the vertex. The vertex has been moved to the right 3 and up 4. So from 0, 0, it moved to the right 3 and up 4, which means that minimum value there, since a is positive, that minimum value is going to be the ordered pair 3, 4, which means the minimum, the very lowest this thing ever gets, is y equals 4. Another method of finding maximums or minimums is that we're going to find the extreme value of a quadratic function, and we find that when x equals negative b over 2a. So this will tell us automatically, this little formula, x equals negative b over 2a, this will tell us where the maximum or minimum occurs. So let's use that to help us find this value. So looking at this, we know a is negative 1, b is 1, and c is 2. So x will equal the opposite of b over 2 times a. So that means x equals 1/2. Now that's the x value for the vertex. The y value is going to be when we plug in a 1/2 to the function. So f of 1/2 equals negative 1/2 squared plus 1/2 plus 2. So this is negative 1/2 squared is 1/4. And that gives us an answer, negative 1/4 plus 1/2 plus 2 is 2 1/4. This is, because a is negative, this is a parabola that opens down, so it has a maximum value. And that maximum value is 2 1/4, which occurs when x equals 1/2. So thinking back to this method, we know that the maximum or minimum occurs at this x value, and we have already talked about if a is greater than 0, the function has a minimum, and the minimum will be at f of negative b over 2a. If a is less than 0, it will be a maximum value at that same exact point. So remember, all we're really doing is finding the vertex in either of these processes. And the vertex will either be the maximum or the minimum, depending on which direction the function opens. So let's first of all talk about this. Since a is positive, we know this has a minimum. And we've got x equals negative 4 over 2 times 1, which is negative 2. To find the value of the minimum, we plug in the negative 2 to the function. We get negative 2 squared plus 4 times negative 2, and that's 4 minus 8, and the answer is negative 4. So our minimum value here is negative 4. When we look at g of x, we do the same thing, but this time we have a maximum. This parabola opens down because of the negative, but the process is the same. Negative b over 2 times a, and in this case we get 1. So to find the minimum, we plug in a 1. Sorry, this is a g function. G of 1 equals negative 2 times 1 squared plus 4 times 1 minus 5. That's negative 2 plus 4 minus 5, and that answer gives you negative 3. So our maximum value in this case is negative 3. The function never goes higher than negative 3. So let's look at a couple of word problems. Most cars get their best gas mileage when traveling at a relatively modest speed. The gas mileage m for a certain new car is modeled by this function. Notice, since this is negative, it's going to have a maximum gas mileage, and the speed is between 15 and 70 miles per hour, where s is the speed in miles per hour and m is measured in miles per gallon. What is the car's best gas mileage, and at what speed is it attained? So if that's our function, we just want to use this little rule. So we're going to have, in this case, s equals negative b over 2 times a. Now with a fraction, it's maybe a little bit more difficult, but we have, notice these negatives will cancel out, so we've got 3 over 1/14 when we multiply the bottom together. And instead of dividing by 1/14, we multiply by 14. That's the same thing. And 3 times 14 is, nope, it's not 52, it's 42. So 42 miles per hour is the speed at which we get our maximum gas mileage. So that's actually the answer to this, 42 miles per hour. Then, to find the actual gas mileage, we're going to take that 42 and plug it in. So m of 42 is going to be negative 1 over 28 times 42 squared plus 3 times 42 minus 31. And grabbing a calculator quickly, we've got negative 1 over 28 times 42 squared plus 3 times 42 minus 31. And we get an answer of 32, and that 32 is miles per gallon. So you can see how this quadratic would show us that information, and actually many times vehicles do get their best gas mileage. Usually it's a little higher than 42. It's typically right around 50 to 55 miles per hour. Okay, in this one we want to use a graphing calculator to find any local maximum or minimum values of the function. So I'm going to go ahead and pull up our graphing calculator here. Now notice as we look at this, the first thing I want to do is I want to go to y equals and I want to type this in. The x key is right here next to the green alpha key, so we have x, we have to use our caret symbol, x raised to the 3rd power, minus 8x plus 1. Then we want to go to our graph, And if we are using a calculator that other people use, a lot of times we want to go first of all to this middle on the top, zoom, and down to number 6 for zoom standard. Oops, number 6. So we hit enter there, and now we're going to see a picture of our graph. And we can see that it has a maximum value right up here. And it's going to have a minimum value right down here. Now, as we look at this, again, we're going to have to find this maximum and minimum, and here's how we do it. We use our second key, and then we go to trace. Whoops, I need to put my arrow back on. So we go to our second key, and then we go to trace. And notice it has two options here, 3 and 4. One is for minimum, one is for maximum. So I'm going to find the maximum first. That one came further to the left, so I'll just find that one first. So I hit enter. Now notice what it asks for. It asks for a left boundary, and then it's going to ask for a right boundary. So looking at this, here's my maximum right here. I just have to pick some x value that's over to the left of it for a left boundary to tell that graphing calculator where to look. So I'm going to choose, let's just choose what? -5. So I'm just going to go to -5, and I'm going to select that as my left boundary. Notice this arrow here? This arrow is telling it that's where we're going to look. We're going to start here at -5, and that's the left, as far to the left as we're going to look. Then it's going to ask for a right boundary, so I need to pick something to the right of this, and I'm just going to pick 0. So I hit 0 and enter. And again, there's an arrow that comes up right here. Whoops. There's an arrow that comes up right here, and so I'm telling the calculator I want to look in this area right here for that maximum value. Then for some reason the calculator asks us to guess. I don't want to guess, so I'm just going to push enter again. And we can see that it gives us this value of -1.6. Let me get rid of that writing. -1.63, so the maximum. The maximum is -1.63. Then we want to find the minimum. So we go again, second, trace. And we're going to go down to number 3 for the minimum. And again, it asks for a left boundary, so this time I'm going to go with 0. And remember, that gives us, this is a left boundary. And then I'm just going to go up to, let's say, 9. It doesn't really matter, just so we pick something to the right of that. So I'm going to go 9, enter. And again, what that does is it tells the calculator we're going to look in between those two values for the minimum, and it will find it right there. So then we hit, I don't want to guess, I just hit enter again. And we find out that our minimum value this time is a positive 1.63. Wow, I can't believe I made that mistake. Negative, remember the minimum value is the y value. So that minimum is not 1.63, it's -7.7. If we round it off nearest hundredth, -7.71. Our maximum, I guess I'm going to have to go back and do that again. So second, trace, second, trace, go down to number 4 for the maximum. And again, I chose left boundary of -5 and right boundary of 0. And I don't want to guess. This time we're going to look at the correct number, so we can see the correct number is 9.71. The y value is the one that always gives you the maximum. And no, I didn't do that on purpose, I just wasn't paying attention. But make sure you pay attention. It's the y value that gives you the maximum or the minimum. So our assignment, back to the PowerPoint, the assignment is for section 3.5 and it's on pages 266 to 269. So go ahead and take a look at those. The graphing and the finding maximums and minimums, you can get started on those, and again, you'll have time to work on those during class tomorrow.